Hi students, we have a new questions in front of you. It's one of the beautiful question I have seen in the NEET. So let's go through it. The question given here is two particles A and B move with constant velocities. Okay, that is V1 and V2. Okay, at the initial moment, their position vectors are R1 and R2 respectively. Please note it is at the initial moment. Now the condition for the particle A and B for their collision is, so in their initial, so when we read this question initially we may feel like, okay, is this question come from work, power and energy? It's because it is talking about collision and all, but actually not. We can do this with the fundamentals of vectors actually. So let's start understanding this question little more deep. Okay, so let's try to understand this, let me say, with more clarity. That is very important. Okay, so let me say this is, so they are talking about what actually? Two particles A and B. So let me denote my particle A with red color. So this is my A, you can see, and I am denoting my particle B with another color green. So let it be anywhere I am putting 2 points. Now they are telling the initial, so since they are talking about, in the question they are talking about their initial position vectors, they are talking about their initial position vectors are R1 and R2 respectively. So I am going to locate this with a coordinate system. Okay, that is the reason why I am using coordinate system here. Okay, so coordinate system, to draw the coordinate system I am drawing the y-axis and let this be my x-axis. Okay, clear? So I will mark this. I hope it is very clear, you know these things. Okay, this is my y-axis and this is my x-axis. Okay, clear. Now let me draw its position vectors. So here for the particle A, I will put it here, the particle A. This is my particle A. Okay, so its position vector, so its position from the origin we draw the position vector. So the position vector is drawn. Okay, so the position vector is drawn. So this position vector is represented by R1. It is given in the question, so there is no doubt I am representing it like this. Okay, so this understanding is very important in this question. And for the other one, at any moment, initial moment, for the particle B, its position vector is given by R2 in the question. So let me draw that and mark it as R2. Okay, now they are telling, the question asked here is what actually? They are telling the condition for the particle A and B for their collision. Now let us assume, so we have a lot of assumptions here. So let us assume this particle is moving in this direction. Okay, like this. Okay, and let us say this particle, let me take another color and say this particle is moving in this direction, like this, moving in the upward direction. Okay, so let me put it a little more beautifully like this. Okay, so we know that if these particles are moving in this and this direction, there is a possibility that at this point this will collide. So let me use here red color, also let me use here green color. So what is the meaning of this one then? Can anybody tell? So this clearly indicates that at this point it is getting collided. Okay, so I can write it here. Okay, I can write it here. This is my collision point. Let me say this is my collision point. Okay, this is my collision point. Okay, so if this is the collision point, I know that this particle A should move from here to here with some velocity v. Okay, so let me put it in red color itself so that it is easy for you to get it. So let me say it is moving with a velocity v1. It's a vector since it's moving in a direction v1 and it needs to travel this much distance. So let me say this much distance means distance is speed into time. So v1 into t, that will give you the distance. So it needs to move like this. Okay, during collision it needs to move like this. Okay, Now similarly this particle should also move in this direction. So what might be the distance it should have traveled? Can anybody tell? Similarly, let me assume its velocity be v2. So v2 into t. And why t is coming in both sides? Because both might have traveling simultaneously, so they must have traveled during the same time before the collision. So both might have traveled at the same time, that's why t is coming here. So what is the new position vector during the collision? We know that during collision both particles should be at the same position, then only the collision will happen effectively. Correct? So I hope that is clear. Okay, let me try to draw that. Okay, so both particles are at the same point. So and its position vector I am representing it with the r. I hope this much is clear for you from this fundamental. Now what we need to do here? So what is the condition I can mention? During collision, this is one fundamental you should know to draw this diagram. What is that? During collision, okay, both will be at the same position. Both will be at the same position. Then only collision is possible, right? Okay, that we can think logically. There is no problem in that. Okay, now let's apply triangle law. So triangle law, how will you apply? You can see here this I am redrawing it. So this is my position vector r. Okay, this is my position vector r, and you can see this is the position vector r1, that is the initial position. Okay, r1, and you can see it has traveled this much to this particular point, and that is v1 into t. Okay, this is r1. So if you apply triangle law, we can easily write what is r here. So I can write r here is, okay, r here is r1 plus v1 into t. This is by applying triangle law. So I will write it here by applying triangle law. You might have learned this in vectors. Okay, by applying triangle law. Now similarly in the second part, here also you can apply the triangle law. Okay, so here also in this part also you can apply the triangle law. So let's say what you will get, sir, in that case. There also I can write the position vector r is equal to how much it will come? I can say r2. Okay, I have not put vector direction here, I need to write that. So vector r2 plus I can write v2 vector into t, and here also what I have applied, the triangle law is applied. Okay, any doubt until this? So from this one, so this is my equation 1. Let me say this is my equation 1. This is my equation 1, and let me say this is my equation 2. Okay, this is my equation 2. Now if you are observing equation 1 and 2, you can understand one thing, LHS part is same. So how I can write this equation now? So see here, I can write it as r1 plus v1 into t is equal to r2 plus v2 into t. Actually this is the condition. Okay, for A and B to collide, this is the condition. But unfortunately, if you look at the options, this one is not present. Okay, so what can be done further? We can see here one more thing. Here R is a vector quantity, V1 is a vector quantity, but T is a scalar quantity. So what we can do here is T can be modified, or we can write an equation for T here. How? So we can rearrange it in such a way that R1, I am taking R2 here, so this will become R2, okay, equal to V2 into T minus v1 into t. Okay, now again let me write it as r1 minus r2, okay, equal to, I am taking t common, so this will become v2 minus v1. Okay, I hope this is clear. Now from this we can write an equation for t. What would be the equation for t here, sir? T would be equal to v2 minus v1, and please remember this is vectors, so we should write that. So t should be, so then this should come in the denominator, sorry, so this should be r1, okay, minus r2 divided by v2 minus v1. Okay, so this is the equation for t I am getting. Now let me mark this as my equation 2, mark this as my equation 2, and let me mark this as my equation 1. Okay, since I could not find equation 1 in the option, what I am going to do is I am going to substitute this equation 2, we need to substitute. But before that you should understand one more condition. That's why this question is very interesting. Here t is a scalar quantity. We know this t is a scalar quantity. Time is a scalar quantity, we all learned. But the term given here is a vector term. So if you convert this vector to a scalar, what we should do? We should do the modulus. So on taking modulus, on very important point in this question, on taking modulus, we can convert, on taking modulus, we can convert this into scalar. We can convert this into scalar. We can convert this into scalar. Okay, so I can say the time can be written as time t is equal to, on applying the modulus, it will become like this. Okay, I am applying the modulus, so this will become r1 minus r2, something like this. Okay, divided by v2, okay, minus v1. Now it is more meaningful. Okay, so this I can consider as equation number 3. Okay, now I can easily apply, or what I can do, I can substitute the equation number 3 in equation 1. Okay, so next step is substitute equation 3 in equation 1. Okay, so what it will become, sir? So if you are applying, I can write it like that itself. So r1 minus r2, okay, equal to, so you can see here time is there, so for time I am applying this one, so that is, you can see here r1 minus r2, okay, divided by v2 minus v1. So it's a magnitude only, v2 minus v1. Then outside that you have, as per our normal equation 1, we have v2 minus v1, that is vector is present, v2 minus v1. Now I can rearrange it in a little more beautiful way, in such a way that I can write it like this. Listen, I can write it like r1 minus r2, okay, r1 minus r2 divided by, I can take, what I can take here, so I can cross multiply this part may come here, this part may come here, so I can write it like r1 by r2. So this is coming from here only. Okay, so this is coming from here, and this is already present here, so this can be r1 modulus of r1, okay, minus modulus of r2, and that is equal to v2 minus v1 vector divided by, already in the denominator we have the modulus, this is present, this is already present, so I can write it like that. So that is v2 vector modulus minus v1. So I hope this is the final condition that is mentioned in the options. So I can check for this option and identify where it is present. Okay. So on analyzing the options, I can say this is present. Here you can see, so this is present as option 2, and hence option 2 is the correct answer for this question. I hope you understood very clearly this question. Okay, if you have any doubt, feel free to put the comment on the box, and still you can contact me via the number that is mentioned in the video. Thank you. If you liked the explanation, please subscribe the channel. You will get more questions with a clear explanation.